Are you ever curious about how your data finds the quickest route through a network? The secret lies in a protocol called OSPF, or Open Shortest Path First. Often, we take for granted the speed and efficiency with which our data travels. However, behind the scenes, OSPF plays a pivotal role. This protocol, designed for internet routing, has one main objective: to determine the shortest path for data packets to take through a network. Now, why is this important? In the vast expanse of a network, the shortest path is not just about distance, but also about efficiency and speed of data transmission. OSPF uses a complex algorithm to calculate this path, taking into account various network variables. This ensures that your data reaches its destination in the fastest possible way. As we dive deeper, you'll discover how to configure and verify OSPF and understand concepts like DR/BDR selection and router ID. To begin, let's explore what neighbor adjacencies are and how they work in relation to OSPF. In the realm of routing protocols, OSPF, or Open Shortest Path First, uses a concept known as neighbor adjacencies. It's a kind of relationship between two routers where they agree to exchange routing information. This relationship is crucial in the OSPF operation, as it allows routers to share information about network topology. Now imagine a neighborhood where everyone knows each other. The same concept applies in OSPF. Each OSPF router maintains a relationship with its neighbors. They keep a constant line of communication, continually updating each other about changes in the network. Transitioning to EIGRP-specific concepts, EIGRP stands for Enhanced Interior Gateway Routing Protocol. It's a Cisco proprietary protocol, meaning it's specific to Cisco routers. One key EIGRP concept to understand is its use of a metric to determine the best path for data. This metric is based on bandwidth and delay by default, but can also take into account reliability, load, and MTU if configured to do so. EIGRP and OSPF have their differences, but they also share similarities. Both use a form of the Dijkstra algorithm to calculate the shortest path to a destination. However, while OSPF uses cost as its metric, EIGRP uses a combination of factors. Another important concept in EIGRP is the use of neighbor tables. Similar to OSPF's use of neighbor adjacencies, EIGRP routers keep a table of their neighbors and the routes they advertise. This table is used to determine the best path for data. In conclusion, neighbor adjacencies are a key component in OSPF's operation, allowing routers to share network topology information. EIGRP, while different, shares a similar concept with its neighbor tables. Both of these protocols use a form of the Dijkstra algorithm to calculate the shortest path, though they differ in their metrics. Now that you understand the basics of neighbor adjacencies, let's move on to the actual configuration of OSPF. Configuring OSPF may sound intimidating, but it's simpler than you might think. Welcome to the third scene of this episode, where we're going to demystify the initial steps of the OSPF configuration process. We'll dive into the commands you need to use and how to read the results. First up, we need to enable OSPF on our router. This is done using the router OSPF command followed by the process ID. Remember, the process ID is locally significant, meaning it doesn't need to match with other routers in your OSPF area. You can think of it as a unique identifier for this OSPF instance on your router. Once we've enabled OSPF, it's time to specify which interfaces we want to include in the OSPF process. We do this by using the network command followed by the network address, wildcard mask, and the area ID. The wildcard mask is the inverse of a subnet mask and is used to match a range of IP addresses. Now let's say we want to configure OSPF on a point-to-point link. In this case, we'd use the IP OSPF network point-to-point command. This tells OSPF that this interface is a point-to-point link and should be treated as such. Once we've configured our interfaces, we can verify our configuration using the show IP OSPF interface command. This will display detailed information about each interface running OSPF, including the process ID, area ID, network type, and cost. The last command we'll look at in this scene is the show IP OSPF neighbor command. This command displays a list of all OSPF neighbors that the router has formed an adjacency with. This is a critical command to understand as it provides invaluable insight into the state of your OSPF network. Remember, configuring OSPF is like building a house. It's all about laying a strong foundation, brick by brick, command by command. With those initial steps completed, you're well on your way to configuring OSPF. Are you ready to continue with the OSPF configuration process? Let's dive right back in, shall we? After designating the router ID and network statements in the first part of the OSPF configuration, we now move on to the next steps. Let's start with setting the area. The area is a critical component in OSPF, which helps in creating a hierarchical network and reducing routing overhead. Use the command area to set the area for the network. Remember, the area ID is an integer value, so you can use any number that suits your network design. Now let's talk about setting the OSPF cost. The cost is the metric OSPF uses to calculate the shortest path. To set the cost, use the command IP OSPF cost. Remember, the lower the cost, the more preferred the path is. Up next, we have the OSPF priority. The priority is used in the designated router, DR, or backup designated router, BDR, election process. To set the OSPF priority, use the command IP OSPF priority. A higher value indicates a higher chance of becoming the DR or BDR. Lastly, let's discuss OSPF authentication. OSPF authentication is used to secure OSPF routing updates. Use the command IP OSPF authentication key to set the OSPF authentication key. Then use the command area authentication to enable OSPF authentication for a specific area. And that's it. You have configured OSPF on your router. It's not as daunting as it seems, right? The key is to understand the function of each command and how they contribute to the overall OSPF operation. Congratulations, you have now configured OSPF, but we're not done yet. Stay tuned as we verify our OSPF configuration and discuss more intriguing OSPF concepts like DR, BDR selection, and router ID. Until then, keep practicing and exploring the fascinating world of networking. Now that OSPF is configured, it's time to verify that it's working as expected. In the world of networking, verification is the key to success. It's what allows us to confirm that the configurations we've made are functioning as intended. So, how do we go about verifying OSPF? Well, it's simpler than you might think. Firstly, we use the show IP OSPF command. This command will provide us with a wealth of information about the OSPF process. It will show us the router ID, the OSPF process ID, and the areas that this router is a part of. If you see the correct router ID and process ID, that's a good sign that OSPF is functioning correctly. Next up, we use the show IP OSPF interface command. This command will show us all the interfaces on which OSPF is enabled, along with their states. You should see the interfaces that you've enabled OSPF on in the correct state. If you see interfaces in the down state, that's a sign that something's not right. Another useful command is show IP OSPF neighbor. This command will show us all the OSPF neighbors of the router. You should see the router IDs of all your OSPF neighbors. If you don't, then there's a problem somewhere. Finally, we can use the show IP route OSPF command. This command will show us the OSPF routing table. We should see all the OSPF routes that the router has learned. If you see the routes you expect to see, then OSPF is functioning correctly. Remember, the goal of verification is to ensure that everything is functioning as expected. If you see anything that doesn't look right, take a step back and review your configurations. It's always better to catch problems early rather than waiting for them to cause bigger issues down the line. Verifying OSPF ensures that your configurations are correct and working properly. So don't skip this crucial step in your networking journey. It's the best way to ensure that your network is running smoothly and efficiently. Before we wrap up, there are a couple more OSPF concepts we need to discuss. Let's talk about DR-BDR selection and router ID. These two are integral parts of OSPF and are vital for its smooth functioning. DR, or designated router, and BDR, or backup designated router, are crucial roles within an OSPF network. They manage the control traffic among routers in a multi-access network such as Ethernet. The DR is the primary manager, while the BDR stands as a backup, ready to take over if the DR fails. Router ID is another essential aspect of OSPF. It is a unique identifier assigned to each router within an OSPF area. The router ID is critical for OSPF routing updates as it helps distinguish one router from another. Understanding these terms and their significance is crucial for mastering OSPF concepts. They enable efficient routing and ensure network stability and reliability. With that, you now have a comprehensive understanding of OSPF. Let's take a moment to review what we've covered in this video. We journeyed into the world of Open Shortest Path First, otherwise known as OSPF. This routing protocol has been a central point of focus, and rightfully so, as it plays a major role in network communications. We began our exploration with neighbor adjacencies, understanding how routers form relationships to share information. It's a harmonious dance of data orchestrated by algorithms and protocols that ensures efficient network communications. We also delved into EIGRP-specific concepts, shedding light on how this advanced distance vector routing protocol complements OSPF in a network environment. Our journey then took us to the configuration of OSPF. We walked through the steps one by one, illustrating how to set up this protocol on a router. We saw how to define network areas, set router IDs, and configure interface parameters. It was a practical, hands-on session that demonstrated the intricacies of OSPF configuration. Next, we verified our OSPF configuration, ensuring that everything was set up correctly. We learned how to interpret OSPF information, a crucial skill for any network engineer. This step-by-step process underscored the importance of thoroughness and precision in network configuration and troubleshooting. Finally, we tackled the concepts of DR-BDR selection and router ID. We learned about the designated router and backup designated router, understanding their roles in managing network traffic. We also discussed how the router ID is chosen and what significance it holds in OSPF operations. Each of these elements plays a crucial role in understanding and working with OSPF. It's an intricate dance of data, with each step carefully choreographed to ensure smooth, efficient network communication. And so, we've come to the end of our deep dive into OSPF. But remember, this is just one part of the vast and complex world of network engineering. There's always more to learn, more to explore, and more to master. And there you have it, a deep dive into OSPF. Stay tuned for more technical training here on TechSpectrum Pro.